Hello, welcome you all. In this video, we will learn about the frequency response curves. In the last two videos, we have derived the response of the mass spring system subjected to forcing function. That is, x is equal to f naught by k. F naught by k is static deflection. That is written as x naught sine omega t divided by square root of, we have two terms here, 1 minus omega by omega n square whole square plus 2 zeta omega by omega n whole square. Okay, this is the response for the mass spring system subjected to forcing function. For the maximum displacement, the sine omega t value, sine function value, it is 1. So we have x is equal to f naught by k and this value, where f naught by k it is written as x naught. So x is equal to x naught by this value. Okay, here we have considered only the response of the first function because of the, we have not considered the response of the free vibration. As the free vibration it lives only for the shorter duration, we have ignored or it considered only for the initial phases. It is also called as the transient vibration. It dies out only for certain time. It is very short time. Okay, the response of the first vibration, it is also called as the steady state vibrations. Okay, this is the equation for the mass spring system subjected to forcing function. Okay, it is the steady state vibration or the response for the first vibration. Response of the free vibration, it is ignored or it, as it is lives only for the shorter duration, or it appeared only in the initial stages. Okay, if this is rearranged as, when sine omega t value is equal to 1, then there is a maximum response or the maximum displacement, that is x max. Okay, x max divided by this term f naught by k, it is x naught. X max divided by x naught, this is called as the magnification factor. Okay, if this f naught by k, it is also x naught. If it comes this side, the ratio of the steady state vibrations to the response of the free vibration, that is x naught, is called as the magnification factor. Okay, as you can see from this equation, it entirely depends upon the frequency ratio and the zeta value. Frequency ratio omega by omega n and zeta. We have only two terms here, frequency ratio omega by omega n and the zeta. Okay, let us study what is the effect of the frequency ratio and the damping. Okay, as the response or the magnification factor, it entirely depends upon the frequency ratios and damping. We are studying on it. Okay, when it is plotted, when the frequency ratio on the x-axis and the magnification factor on the y-axis, okay, by taking different values of omega by omega n, that is 0, 1, 2, 3, 4, 5 on the x-axis, and taking different zeta values, what can be learned here? Okay, this is the graph. Okay, by substituting different frequency ratio values and zeta values, okay, we get this curve. This curve is called as the frequency response curve. Frequency response curve. Okay, here for omega by omega n equal to 1, we have got maximum displacement for all the ranges of zeta. Okay, see here, as the value of zeta increases, 0, 1, 2, 0.2, 0.3, okay, the value of magnification factor, it decreases. And here we have one more graph, it is the phase difference. Okay, when omega by omega n is equal to 1, then the magnification factor, okay, it is infinity. Omega by omega n equal to 1, the magnification factor, it is infinity. This is magnification factor 1. Okay, magnification factor, when it is less than 1, then the zeta values are more than 0.6. Then what can be seen from these graphs? Omega by omega n. Okay, for all the values of zeta, the phase is 90 degree at omega by omega n equal to 1. What do you mean by omega n? Omega n, it is the frequency of the system subjected to forcing function, and omega n, it is the natural frequency of the system for the free vibration. Okay, the phase is always 90 degrees for any values of zeta. It is independent of the zeta. And when omega equal to omega n or omega by omega n equal to 1, in that case phase is 90 degrees. Okay, the same thing it is explained here. Okay, what are the observations here? At resonance frequency means omega by omega n equal to 1 or omega equal to omega n. Okay, the phase is 90 degrees. At resonance frequency, magnification factor is infinity. The same is explained here. At resonance, that is omega by omega n equal to 1, this value, it is infinity. Magnification factor, okay, it is endless here, so it is infinity. And damping reduces the magnification. Okay, as the zeta value increases, see here, zeta value it is 0, 0.1, 0.2, 0.3. okay, as it increases, zeta value decreases. Okay, the same thing, it is the 0.3. Maximum amplitude occurs to the left. Okay, this is the maximum amplitude. It is left side of this frequency curve. And the magnification factor, it is always less than unity for all damping values which are more than 0.6. okay, zeta value it is 0.3 here. Next, zeta 0.6. when zeta value more than 0.6, always the magnification factor, this is the maximum value, it is 1. Okay, if the zeta value is more than 0.6, then it is always less than 1. Okay, in this zone. If there is no damping, then the phase angle is 0 or 180 degrees. Okay, substituting the value of zeta equal to 0 here, we get the phase that is 0 or 180 degrees. Okay, these are the observation from the frequency response curve. Frequency response curve means it on the x-axis we are consider the frequency ratios, and for different values of zeta, magnification factors are shown. What is magnification factor? It is the ratio of the response of the steady state vibration to the static response. Steady state means it is mass spring system subjected to forced vibration. Static means it is subjected to F naught, static value of the force. Okay, now we will see for omega by omega n, when it is very small value, then the inertia and the damping forces are small. Okay, it is shown here in this figure. When the inertia force m omega square, it is small, damping force is also small, so you will get this phi value also very small. When omega by omega n equal to 1, you will get the inertia force which is almost or more than spring force, then you will get this phi value, it is 90 degrees. Okay, similarly when omega by omega n it is larger value, okay, then damping and spring forces are very small, and obviously the inertia force which increases, so the phi value is more than 90 degrees here. Okay, these are the observations from the frequency response curve. Frequency response curve, it is taken from this equation for different values of frequency ratios and zeta. Okay, frequency ratios, it is in the abscissa or the x-axis, and in the y-axis magnification factor values are recorded for the different values of zeta. Okay, thank you.